Welcome, my name is Craig Otto. This is Statistics for SPC, Operational Excellence. This is the third part of the normal distribution discussion. And for this part, we're going to get into how to use the calculator and even a little bit of Excel on calculating probability for area under the curve. And so that it's going to basically look at, from the normal distribution standpoint, you have a left bound, a right bound, mean, and standard deviation. Those are your four what I call inputs in order to get your output. And the way that you would type it in, for example, on the calculator, would be normal CDF. You have your left bound of the curve, meaning the left start point on the curve to the right start point, and then you have the mean of the distribution and the standard deviation. And that's kind of how you plug it in. And I'll show you an example how to do that. Something to note that whenever you hear less than or greater than, for example, if the problem says less than a certain number, the left bound goes to negative infinity when it's less than. So on the calculator, there is no negative infinity. So what I usually do is type in that 1e99, or in this case for negative infinity, negative 1e99. So that's what negative infinity is, and then positive infinity is 1e99. So just a quick note on that. Also, we're going to talk about going backwards. So instead of trying to find the area under the curve, let's say you have an area, but you want to know what is the bound, or in other words, the z-score of what you're looking for. So with that, we'll go ahead and get started. Just run through a couple of examples here. This first one, adults' IQs are normally distributed with a mean of 100, standard deviation of 15. They want you to find the probability that a randomly selected IQ is less than 112. Okay, so again, I mentioned that less than is negative infinity, and on this example they type it in as minus 99999, and I would highly recommend, instead of typing that, I would type in negative 1e99, and you'll get a more accurate answer. Not that this one will be off by much, but again, it's just another way to be a little bit more precise. So with that, what you do is you go into your second vars on your calculator, go to the normal CDF, and then you hit enter. And what will come up is this first normal CDF with the parenthesis. And what you type in, again, in this case, because it was less than, remember the calculator thinks from left to right. So in terms of the distribution, less than 112, your left bound or your left start point is your first number. So the first number is negative infinity because it's less than, so you type in 1e minus 1e99, or in their case they typed in minus 9,999. Your right bound is next, so the right point that you want to go to is 112 because it says 112 or less. So you type in 112, and then the last two inputs are your mean and your standard deviation. So your mean is going to be 100 from the given example. You see the little mu there, mu equals 100, so that's your third input. And then your fourth input is this standard deviation here, this sigma, equal to 15. So that's your last input. And then you just hit enter on the calculator, and you'll get the 78.8% as your answer. Okay, so that's just one example. The next one, it says find the probability that the IQ is at least 122. So at least 122 means 122 or more. So in this case, the first thing we got to do is go in, find your normal CDF, and the first thing you want to type in is your left bound, or as they put it in the example, the smaller number. So in this case, the smallest number, because it says at least, is 122. So that's your left bound. That's where they typed in 122. And then your right bound, because it's at least 122, it goes to positive infinity. Okay, so positive infinity is typed in as 1E99, or you can type in as they do 9,999. The third input is your mean, which we know from the previous example was 100, and then your standard deviation of 15, and then you hit enter, and you come up with the 7% there. So 7% falls underneath the curve. Okay, now we did a less than, we did a greater than. Now what we want to do is find the probability between two different numbers. And the way that you do that, again, is the same as always, normal CDF. And you type in your left bound number, or your smallest, which is 112 in this case. And we want to know how much is between 112, and then your right bound is 122. So those two numbers are what you'll be typing in. So 112, comma 122. Then you type in your mean, and then your standard deviation. So it's 100, and then your standard deviation was 15. And let me do the, well, they did the math there for you. It's 14%, 0.1406. So that's how much area falls underneath the curve between those two numbers, or in other words, probability. Okay, so the calculator, a lot of the previous sessions, the two normal distribution sessions before this, we spent a lot of time, I guess, doing things by hand is what I'll call it, versus pressing the button and it spits it out for you. I think it's important that we did it by hand at first. You know, a lot of people want to jump right to the calculator, but I think you miss a lot of the understanding of how this all works if you don't try to do it by hand initially and work through it. But now that you have the calculator, hopefully it's quicker for you and it makes a little bit more sense. Okay, alright, so here's some examples. And one of the things I tried to do in these particular examples is I wanted to show you what you type in Excel, so that you're familiar that if you don't have a calculator, if you're at work and you don't have a TI-83 plus, you can still do this in Excel and get the same results. So I put that information up here. The white is basically how you type it in, and because this is a normal distribution, like on a calculator, if you know it's a mean of 0 and a standard deviation of 1, you actually don't need to type that in. The calculator will assume it. So in the calculator, the first question here, what's the probability of getting less than 0? Remember, 0 is our mean, so 0 or less is 50%. But let's do it on the calculator so that it makes sense here. If it's less than 0, that means it goes to negative infinity. So that's why I said type in minus 1E99 and then comma 0, because 0 is your right bound, or your largest number. And then you don't need to type anything else in because it assumes, the calculator assumes a mean of 0, standard deviation of 1. So you hit enter, you get your result, which is 50%. Now you can also do this in Excel, and the Excel basically also thinks from left to right, only the trouble is where the calculator you can type in left bounds and right bounds. In Excel you can only type in one number for a bound. So it gets kind of tricky in how you do it. Now I'll talk about that in a second. You know, for this first one in Excel, your mean is that first number there is 0. Well, that's talking about this probability number being less than 0. And then the second 0 is actually your mean, and the standard deviation is the third one. And then the next part is you want to enter true. And what that does, instead of making what true will do is make it a CDF instead of a PDF. So if you had put false in there, it would actually use the probability density function versus your cumulative function. So you want to make sure you have true in there, and you should get the same answer, 0.5 or 50%. If you do the same thing on the next one, again on the calculator, it's much easier because you can type in left and right bounds. So in this example, what's the probability of the data falling between -1 and 1? Well, on the calculator, you just type it in -1 and 1. Assume 0 for mean, 1 for standard deviation. Press the button and out comes the cookie. It's 68%, which we've known from the last few sessions that that's true. Now, if you want to do that same calculation in Excel, it gets kind of tricky because Excel, again, you don't have a left bound and a right bound. You only have one number that you can type in. So what you have to do is you have to find the area from -infinity all the way to 1. So that's how you type this in. So from -infinity all the way to 1, it's a probability under the curve from 1 or less. But because we don't want all of that, we only want from 1 to -1, you actually have to subtract out the area from -1 to -infinity. So to do that, the calculator thinks from left to right, so you're going to take the probability of 1 and less, subtract out the probability of getting -1 or less, and that's going to give you the area between those two numbers. And I highly recommend you draw a picture of this and shade it. In other words, if it's looking from left to right, make a histogram, mark your line at 1, your mean of 0 is the center of the distribution, and shade it in from -infinity all the way to 1. So that's the area for that. And then below that picture, make another picture and put on there the 0 at the highest point of the curve, and then a -1 would be to the left of that, and then shade that area in from -1 to the left. So what you're doing is you're taking that first curve, the area, and subtracting out the second curve, and that leaves you with the distance between, or the area between those two numbers. So hopefully when you draw it in a picture, it'll make more sense. Okay, next one. What's the probability of falling between -2 and 2? Again, type it in on the calculator. It's really quick. It's 95%. If you do it in Excel, same thing. You got to go get the area from -infinity all the way to 2. Subtract out the area from -infinity to -2, and that's going to give you the area between them, and it should come out to 95.44 as well. Something I noted in here, and I didn't call it out, but I want to make sure in Excel all of your formulas have to start with an equals, otherwise it won't know that it's a formula. I just want to make sure that's clear. Next one is the probability of going between -3 and 3. Basically, actually I have an error here. The actual, hopefully you guys caught this too. Instead of normal CDF -3 and 2, because that's not what it says. It says between -3 and 3. So we need to make sure that's actually not a 2, but a 3, and you should get 99.73. And then the Excel formula, that one looks right. So you're going to go from 3 to -3. Okay. Now, what's the probability of the data falling less than 2? In Excel, it's pretty straightforward. It thinks from left to right. So from -infinity up to 2, it's true, it's a CDF. It's 0, it's 1. It should come up with 97.72. And for the calculator, again from -infinity on up to +2. So you got -1e 99 and up to 2, and that should spit out 97.72 as well. Okay. Alright, so next one. Now instead of using the standard normal curve where you have a mean of 0 and the standard deviation of 1, that's going to kind of change up here. So I'm going to change the given. For this particular one, it's going to be a mean of 19, standard deviation of 0.7. Okay. Now the question is, what's the probability of getting 20 or less? So in Excel, you're going to have your thinking from -infinity on up to 20. So 20 is your number that you put in, and your mean is 19.7 is your standard deviation, and it's a CDF, so it's true. Okay. On the calculator, you're going to go left bound, which is negative infinity, and then right bound, which is 20. And I'm going to do this as I'm talking so I can get the answer here. So you get a normal CDF. My left bound is minus 1E99, comma. My right bound is 20, comma, and my mean is 19, comma, and 0.7 for my standard deviation. Hit enter, and you should come up with 92.3%. Okay, same thing in Excel. You should get 92.3%. All right. Next one, we changed the givens around. Now we have a mean of 86.5, a standard deviation of 6.9. I'll let you guys go ahead and plug these numbers in. Now, again, in Excel, you got to be careful. You're going to have to do a 1 minus the curve. So, the calculator thinks from left to right. So it's going to, when you type in 71.2 as the number, it's going to give you the area from negative infinity to 71.2. But you want 71.2 or greater. So the nice thing about the normal curve, probability adds up to 1, right? Probability always adds up to 1. So if you want, when you type it in Excel, it's going to give you from negative infinity to 71.2. All you got to do is subtract it from 1, and you get your answer. God bless the calculator, because that is much easier. You just type in your left bound. 71.2 is your lower number, or greater, so that's going to be positive infinity, or 1E99. And I'm going to start typing this in along with you. Alright, so 71.2 is left bound, comma. 1E99 is my positive infinity. And my mean is 86.5, comma. And my standard deviation is 6.9. And I hit enter. And I should get 98.67%. Or 0.9867. Okay. Next example. Again, we're switching the mean and the standard deviation around. Your mean is actually 27, standard deviation of 1.1. The question is, what's the probability between 26.9 and 27? Okay, so now we're not talking about less than or greater than. We're talking about between two different numbers. So to do this, we need our left bound, which is always your lower value. In this case, it's 26.9. My right bound, which is always my higher number, is 27. And then my mean, in this case, is also 27. And my standard deviation is 1.1. Okay. So then I hit enter to get my answer. And it's 3.62%, or 0.0362. Again, switching things up. We got a mean of 16, standard deviation of 4. The question is, what's the probability between 15 to 21? In this case, we're going to have to type it in the calculator as your left bound of what? What's your left bound? Give you a chance to think about it. Left bound's always the lower number, so in this case it's 15. My right bound is what? My right bound will be 21. And my mean is 16. And my standard deviation is 4. Okay. So when you hit enter, you should get about 49.3%. 49.3%, 0.493. Okay. Next example. I get into some bigger numbers here. 1500 as a mean, standard deviation of 50. And I want to know what's the probability of 1425 or more. So here's one of those. I'll let you think about it. What's your left bound? What's your smallest number? And in this case, it's 1425 because it says 1425 or more. So it means we're bigger. So my left bound's 1425. My right bound is what? Because we're talking about or more, that means it goes on forever. So it's a positive infinity, or 1E99. should have mentioned it sooner that when I say 1E99, on your calculator, it's the EE button. When I say 1E99, that's the E you have to hit. So that way it's not confusing for you. I apologize for not pointing that out sooner. It's the double E button on the calculator. Alright, so I need my mean yet, which was 1500. I also need my standard deviation of 50. And I come up with 93.31%, or 32%. It's 0.93319, so forth. Okay? These are all probabilities of, if you have this mean and standard deviation, that's the probability of it falling between those numbers. It's basically what we're figuring out. Last one, let's get a little bit smaller in numbers. Make us think a little bit more. Alright, so mean of 0.01 and standard deviation of 1,000th. Probability, we want to know what is the probability of getting 69 thousandths or less. Okay, so we got to think about this. What's my left bound? It's my leftmost point. We said or less than that 69 thousandths. So that means that's going to be our left bound. It's going to be minus 1E99, negative infinity. Okay, and my right bound is the greater number, which in this case is the 0.0069. Alright, and then I plug in my mean, which was 0.01. And I plug in the standard deviation, which was 0.001. And I get, what do I get here? So 9.6767, but it's times that little e to the minus 4. That means it's times 10 to the minus 4. So technically, this probability is very small. What that minus 10 times 10 to the minus 4 means is it's 4 decimal places to the left. So I'm talking about 0.00000967. So it's a very small number, very small probability. Okay. Hopefully that makes sense for you. Okay. Now what we're going to do is, sometimes we'll have a probability that we want in mind, but we need to figure out what the number is from that probability. And I'll give you an example. This is one that I always use with my dad. He's a farmer. A farmer's field will yield about 60 bushels per acre with a standard deviation of 7. And the thing about a farmer is they can lock in or sell grain ahead of time at certain prices if they lock in and commit to those prices. So why not use statistics to figure out what's the right thing to lock in at, or how many bushels per acre should they commit to the elevator at that price. So the question is, how many bushels per acre can he commit with a 5% probability that the field will not yield what it needs? In other words, when you're a farmer, if the field doesn't yield enough to what you committed to the elevator, you have to pay for that. You have to basically buy the grain to fill the contract if your field doesn't perform as well as you thought it was. So there's risk on the farmer's end when they lock in these contracts. So what I'm trying to show here is that you can use statistics to kind of calculate how many bushels per acre the farmer should lock in this case. So the way that you do that, you use inverse norm on the calculator, and I'll show you where that is here on the next example, but it's basically close to the same spot as your normal CDF. It's just inverse norm. You type that in 0.05, which is your probability of 5%, and then you type in your mean, which in this case was 60 bushels per acre, and your standard deviation, which was 7. So when you plug that in, it comes out to 48.486. And what that means is a farmer can commit to the elevator that, basically I can lock in or make a contract for my field to yield 48 bushels per acre. and the probability that I get stuck having to pay for that contract because if the yield wasn't what I thought it was is only 5%. So I'm basically 95% confident that I can meet that contract at 48 bushels per acre. So just to try to throw some practical examples in that may relate to some people. There's not everyone's a farmer, but it's kind of neat to see that it really can be applied to anything. Here again, as I mentioned, I'd show you how to do it in the calculator. It's still under the second bar's distribution. It's actually number 3, the inverse norm. And in this case, it says find the z-score for an area of 0.25 to the left of the z-score. So again, the calculator thinks from left to right. So when you're talking about area, in this case, you can see they just type in the 0.25 and they hit enter. When you don't put in the mean and the standard deviation, the calculator assumes that the mean is 0 and the standard deviation is 1. So just to clear up. And here's another example. Find the probability that a z-score is between minus 1.5 and 2. This goes back to the whole standard normal curve again. And what I'm showing here is you can basically you don't need to enter the mean and the standard deviation. It'll assume that it's 0 and 1. So just kind of highlighting that again. Okay, let's do some problems. So if we have a mean of 0 and a standard deviation of 1, what we'd want to do is, the question is, what is the z-score for 90% probability? So what you do is you basically just type in inverse norm and enter your 0.9, which is your 90% probability, and that'll spit the answer out. Now, you can also do the same thing in Excel. That's what the top formula is. It's equals norm inverse, or INV. You type in the 0.9, and then on the Excel, you can't just hit enter with 0.9. You got to tell it that it's 0 for the mean and 1 for the standard deviation. So when you type that in, inverse norm 0.9, you get 1.28. Doing the same thing for what's the z-score for 5% probability. We're going to use that 0.05. So I type that in, inverse norm of 0.05. It's 0 and 1 is the mean and standard deviation, so you don't have to enter anything. Just hit enter. And you should get a z-score of a minus 1.64. Okay. Next question, same thing, or same given, and now we want to do a 1% probability. So you have to do inverse norm of 0.01. And that one is a negative 2.326. Okay, now we're going to switch it up a bit. Now instead of assuming the standard normal curve, you're going to have your mean of 16 and your standard deviation of 4. So you got to be conscious of that. Now the question is, what's the number excuse me, for the probability of 10%? Well, you have to do inverse norm yet, but it's going to be inverse norm of 0.1 and then comma. Don't forget to add your mean. So your mean is 16, then add your standard deviation, which is 4, and it'll spit out the number, which is 10.87. Okay, so at 10.87, that's where 10% of the curve falls from that number and to the left, or to negative infinity. Okay. Next one, 1550 is the given, and your probability that you're looking for is 40%. So, pretty straightforward. Inverse normal. 40% is 0.4 in decimal, comma. And then we have our mean, which is 1500, comma. Then we have our standard deviation of 50. And when we plug and chug, it is 1487.33. So at 1487 and less, that is where your probability is 40%. Okay, last one. Given is 0.01, standard deviation of 1,000th, and we want to know what's the probability of 99%, or what number is it for 99% probability. So to do that, again, 99% probability, we just type in inverse norm of 0.99, okay, and then 0.01 for mean, and standard deviation is 0.001 for that. Type enter. So at 0.0123, that will give you a 99% probability. So 0.0123. Okay. Alright, well that concludes our section on normal distribution, and look forward to seeing you next time.